Hello. Hello. So I'm Nick Koo. I'm a freelance iOS developer. I've been making apps for iPhones and iPads since iOS 3, so the last 5 or 6 years. And one thing I've found is that I've actually grown to quite enjoy programming in Objective-C. As verbose as it is, I know how it works, and I know how to make apps in it. So one of the reasons that I decided to, and this is actually one of the reasons that I've come to talk about the new technologies in Swift, is because this was an experiment for me to learn Swift, to start programming with new iOS 8 APIs, to get myself out of my comfort zone. And so, yeah, that's the reason behind this talk. So, old dog, new tricks. Hopefully that kind of is self-explanatory. Swift was launched by Apple WWDC last year, and looks set to replace Objective-C in the coming years. So my feeling is don't get left behind in what is probably going to become a dying language. I don't know if that's controversial, but it seems to be that's what the powers that be seem to be suggesting around the internet at the moment. So I've been keen to learn Swift, which is one of 3 parts to my talk tonight. One of the main ways that I like to get up to speed with new technologies is hands-on, is diving in, implementing them into a project. So as part of this talk and as an experiment of my own, I've been building this app that you see here, and basically it's backwards compatible to nothing. So iOS 8, Swift, the Apple Watch, and so the name of my app, and I'll tell you a little bit about it, is Glued. It's an idea I had a couple of years ago, and I've only really I've looked at programming it a few times, and it's just been a really nice way for me to get up to speed with Swift and all the latest tech, and which, as we'll see in some of the slides that are coming up, the two have worked really well together. So basically, Glued is a fun, universal app that's aimed at parents to remotely track their kids' iPad and iPod usage on a daily basis. So the idea is that they're going to be able to check their phones, and in fact, this is me checking my own device usage. So the idea is that you set a time limit, daily amount of time, maybe 2 hours, and the app updates. The idea is it's supposed to be fun as well. So because it is kind of opt-in, you can't, unlike Android, you can't really like lock the kid into keeping that app open in the background all the time. There are always ways around it.
Sort of surveillance,
it's fun sort of surveillance. Yeah, it's you've hit the nail on the head. But yeah, but the idea is kind of opt-in. So for example, I'm going a little bit off track, but so there's kind of audio and background location to kind of keep it running. But the parent is going to be able to like record custom alert messages to the kids, so that they can say, "Finn, get off your iPad. You've been on it for 2 hours," or whatever, and it's actually going to like play when they've kind of overrun on Clash of Clans or whatever. So that's a bit about the project. So yeah, 3 key topics I'm going to cover. And just to be clear, this is very much a kind of beginner intro because I am a Swift beginner here. So it's what I've learned in the last sort of 2 or 3 weeks, and a few kind of tips and tricks, especially in the second part in the adaptive layout and universal storyboards, that hopefully there'll be something in there for most who are interested in iOS and moving forward with these new technologies. All right, so we're going to kick off with code and Swift. What's so great about Swift? I surprisingly found it quite easy to learn. Once you kind of get over these crazy error messages that the compiler keeps chucking up, and once you work out what the hell's going on, then it starts to make more sense. For people who are developers coming from other programming languages, the syntax is modern, looks somewhat like Java, a bit like JavaScript possibly. So Anyway, as an Objective-C developer, the cool thing is that one can work with all of the foundation and UIKit APIs that we've come to know and love in Objective-C using Swift syntax, as we're going to see shortly. It's succinct, flexible, and modern. So succinct being the opposite to verbose. So it is quite refreshing coming from Objective-C background to just see in just like a few lines of code the sort of thing that you can do that you used to have to do in like 10 lines of Objective-C. So that is incredibly refreshing. And the more and more you get used to the language, quickly find yourself reducing code verbosity. But Swift is strictly typed, but sort of implicitly, as we'll see in this example, in fact. So this is Objective-C, and here we're declaring a property of UI view in, say, a class, and then we're instantiating that UI view. So the equivalent of this in Swift looks a bit like this. So one thing that I really like is this thing called type inference. So whereas here we're having to define that my view is a UI view, with Swift you can, that's optional, you can include that, but the compiler basically knows it's a UI view because that's what's on the other side of the equals sign. So simply by doing that and instantiating a UI view as equal to my view, from then on the compiler says if it's not a UI view, then it's going to fail. All right. So having lots of apps and client apps that were all built in Objective-C, one of my first questions was how well will Swift and Objective-C work together? And this was clearly a concern. So can I use Swift in an Objective-C project and vice versa? And it turns out the answer is yes, and it's pretty straightforward. And it was clearly an important factor for Apple to factor in order to get large-scale adoption. Okay, so a little video here. What we've got is basically a pretty much an empty Swift project, and I'm a fan of CocoaPods. And for anyone who hasn't heard of them or doesn't use them, it's basically a very easy way to integrate third-party code, third-party libraries and components into your app. So we've got a CocoaPods project here, and in the bottom you can see we've got an SV progress HUD, which is a third-party component. It's basically a progress modal view that's going to and the key here, what I'm trying to point out is I want to use third-party Objective-C classes and libraries like this in my Swift code, and the question is how to do that. So if we play the video, so here we've got a Swift view controller. So yeah, this is what the project looks like. Here we've got a Swift view controller, and if this was Objective-C, we'd simply do an import SV progress HUD, and we'd be able to work with it. And what I'm laboriously showing you there is that that's not going to work in Swift. So what's the solution? How do we use Objective-C classes within our Swift code? So the answer is basically it's called a bridging header, and this enables us to switch to use both Swift and Objective-C classes in the same project. And the way to do this, so this is a Swift project. We're going to create like a temporary. We're just going to create a test Objective-C class in our Swift project. Now Xcode is going to recognize that this is a Swift project, and so it's giving us the option. It's basically going to do all the work for us here. So it's going to say, so you want to use Objective-C within Swift. And so now we get rid of our test class because all we're interested in is this bridging header thing, which we'll see in a second is empty. But this is where we import our Objective-C classes. So now we just import our CocoaPods SV progress HUD. And by the magic of Swift or Xcode or the compiler or whatever it is, we now jump back to our Swift class, and we can literally start using Swift syntax to reference and to create instances of an Objective-C class. So yeah, that's pretty awesome. And that video is almost finished, but hopefully it will prove the point. There you go. Yeah, whoop! I've got a bunch of code in GitHub that everyone who's interested can download and check out, and I also show you in that how to do it the other way around. So if you want to start using Swift classes within your Objective-C projects, it shows you how to do that. And it's slightly different, but it's pretty straightforward. All right. So back to the lack of verbosity. So in Objective-C, we've got mutable and immutable arrays. So the way that we create, so this is how we create a mutable array by using the var keyword. So this is an array which is strictly typed to only allow strings as the elements. And again, we didn't even have to define that on the left. It's implicitly implied, and the compiler now understands that this is an array. It's mutable, so it will allow us to append and add additional strings, but only strings. So unlike Objective-C, Swift is strictly typed, I think like Java, to only allow whatever we're. So then our second example is again, we're creating an array of the same type, but this is an immutable array. And so the var and let, var is a variable, and we can make changes to it, and let is a constant. So this is a constant variable that can't be changed. So if we try and use append, so it's the equivalent of an NS array and an NS mutable array. And the compiler at compile time will throw up these errors. So that. I think we've jumped. No, we haven't. All right, so we're going to go and take a look. I prefer to dive into like creating a class and see how this all kind of works with a class. So, okay, so we create a new Swift class, and what we find is, unlike Objective-C, where you've got an implementation and an interface, 2 files for every class, there's no such thing in Swift. Again, it's very similar to numerous other more modern programming languages. So we get a single file, a Swift file, with our class, and we can actually have multiple classes within a single Swift file. What I really like as well is you don't actually, it's like Xcode treats, or the Swift compiler treats all the code in your app like it's a module. So you don't actually have to include any code that you reference that's also in your project. It just kind of knows about it, although it's quite slow, and I'm sure that will improve in the future, the Swift compiler. Because I've created this person class here, I can go back to my app delegate, and without including anything, I can start creating a new person, and it will recognize what I'm trying to do and give me all the code hinting that I'm expecting without having to do any including. And you might notice that our class of person is a base class. It's not inheriting from NS object like you have to do in Objective-C. So you can create these base classes, which is also pretty useful. Now, one thing I'm trying to highlight here is that this code is going to actually generate compile time errors. And the reason behind this, we've returned from initializer without initializing all stored properties. So basically, we've declared that our class of person has a property, and it's a string, and it's called name, but we haven't given it any value. And we either have to basically give it a value at this point, so we can have an inline var name string equals Nick, or we've basically got until the end of our designated initializer here in which to set a value to that property. Otherwise, we get this error here, which okay. We'll come back to how do you deal with a property that you optionally might want to be nil in a minute, and you'll see how that's handled in Swift. So this is how we solve that previous problem. We've added another property of our person class is talking, and it's a bool. So this is every property that we add with this very, very base level syntax is public. So by default, everything's public. So we can access name, we can access is talking from our app delegate or anywhere else. So if we optionally want to start creating private interface, like we might have within our implementation file of an Objective-C class, we add the private keyword, and then is talking is no longer accessible from outside of this class. Okay, so like in Objective-C, we're used to getters and setters. So we've got a property, and then it's backed up by an instance variable hidden under the hood, which stores the value of that property. So there's basically these things called property observers in Swift are the closest thing that we've got to getters and setters. And we have, so basically in line, so we're creating this is talking variable, and we've got these optional kind of internal functions, and we've got did set and will set. And basically, let's say this is a string rather than a bool, and we want to know what the previous value of that property was. Within did set, you automatically get access to a variable called old value. So if you need to make a comparison and see what's changed, it's just super easy. I've really come to love the language. All right. Okay, here's where we get to the point where you can have a property with a nil value. So optionals. So optionals are wrapper objects. They wrap strongly typed variables. But they permit those variables to be nil, so that's where we get this kind of box analogy here. So and the question mark signifies that name is either going to be a string or it's going to be empty. So it's wrapping either a string or it's wrapping nothing. And that's how we deal with nil. So there's no more NS not found, is this integer equal to -1, therefore it didn't exist. So it's super simple. It's basically either it has its value that it's strictly typed to, or it's empty. And then moving on to the green exclamation mark here. So this is basically saying if this conditional runs, then name has a string value. But the compiler is still the compiler is going to complain about this without the exclamation mark because it knows it's an optional, and so it says, well, you're an optional, so you might be nil, so you haven't covered all the cases. You'll find lots of examples for how to kind of improve this syntax, but that's just trying to. So the exclamation mark is basically, it's called forced unwrapping. So it's basically saying, I know that this is an optional, but I know that it's got a value, and obviously that value will be equal to the type that I've given you. So it's going to be a string, so accept that. And otherwise it's going to crash if it isn't. Okay. Okay, so I touched on this earlier, but arrays in Swift, unlike Objective-C, are typed arrays. So we can't chuck in. So we can only in this example. So we're creating a mutable array called presenters, and we're passing it types of instances of the person class. So here's the syntax for actually creating like an empty array that only accepts instances of the person class. So you've got your kind of square brackets, and then you wrap those around the class type, and then your brackets create a new instance of that variable, of that array. Likewise, dictionaries, both the key value and and the value are strictly typed in dictionaries now. So here we've got a dictionary with string being the key and instances of person being the value. So same principle here. Hopefully that makes sense. Feel free to chuck in any questions if anyone has any along the way as well. And this is
the obvious question. Sorry.
Yeah, go.
If you do want, like classically, you have dictionaries to pass lots of different things back of different types. So.
Right. So that hopefully is going to be answered right here. So in Cocoa APIs, which do exactly that, where the key could be, say, a number, a string, and then the object might be, could be pretty much any kind of pointer. In the Cocoa APIs, that's what this translates to. So like an NS notification that passes a user info dictionary is going to be strictly typecast, but kind of loosely strictly typecast, because it's basically saying this is kind of like a top-level object where we can have any NS object being the key, any NS number, string, and its value can be anything as long as it adheres to the any object protocol, which basically, I guess there isn't really one, but so that's how they managed to translate that.
What's the difference between, because I had an error that was like any object, right? But I assumed that was going to be any object, but then I have to use any. What's the difference between any and any object?
I'm going to have to chuck that out to the floor. I'm not sure. Nope. I'm going to have to come back to you. I'm sorry. To be honest, this is a learning curve for me too. So I'm like 3 weeks in with Swift. I don't know. Sorry.
Have you seen anyone use that object thing in real life code, in Swift code? Just because coming from a Java perspective, if you use object as a type in a hash map, it'd be quite bad. Generally you wouldn't do that because it's kind of janky code. And I wondered if you'd seen it in the any documentation, or whether it seems like it might be an anti-pattern to me.
Yeah, no, it's pretty rare. You're usually going to get if you've got string as the key, it's usually going to be the key for all of your objects. But in the notification center, where something happens, so in iOS, if something happens over here, you can dispatch, hey, this has happened, through the notification center and pass a dictionary, which is totally flexible in terms of what you could be passing, especially as the pointers. So it needs to be kind of, it might be there might be a reference to the sender and I don't know, an NS number wrapping an integer, which you don't have in Swift anymore. So you can literally pass an integer as a property, whereas you used to have to wrap it up in an NS number in Objective-C. Okay, closures, right. So like Objective-C blocks, closures in Swift, they're self-contained blocks of code that basically can be passed around as variables and allow us to, they enable versatile asynchronous application code. Okay, so everyone hated the syntax for blocks in Objective-C, and they haven't got a lot better. They're a tiny bit better, but this is the very basic syntax for a closure, the equivalent to a block now in Swift. So on the left, you've got your green brackets. Now those are, so everything's surrounded by these curly braces, and then after this in bit, it's well, I'm going to show you an example in a minute, but the green brackets basically, when this block completes, send back these parameters, and those parameters you're going to list within the green brackets there. The purple brackets basically enable you to take that even further and list parameters that the receiving code can then send back to the completion block, can send back to the closure. So often those purple brackets are going to be void and nothing really gets sent back. Okay, yeah. So if you need, so there was a great website set up for Objective-C for people like myself who just can never remember how and when to declare Objective-C blocks as parameters, as whatever variables, and that website was fuckingblocksyntax.com, and that's kind of like one of my favorites, and they've added an equivalent for Swift, which is useful if you get stuck. So let's take a quick look at a closure example. So downloading an image from the internet, for example. So here we've got a function, a Swift function that accepts two parameters. One's going to be a URL for that image, and this second parameter is basically a completion block, a completion closure. And this green code here signifies that's the closure. So the closure is basically saying call the completion and pass back an optional image. So that could be nil, say, if it had failed, and you might want an NS error in there as well. And again, so it's saying, yeah, that, like I said, there aren't that many examples where you're going to really want to have anything other than void on the right-hand side. So this is us now calling this method. So closures and blocks are often the last parameter thrown in and passed to a method, because basically it's like, when you're finished, this is what we want to do next. So on the basis of that, Apple have added something called trailing closures. So even though we're actually download an image takes two parameters, because the last one is a closure, we can use this trailing closures idea, which basically says we are chucking in everything in green here as the last as the closure block, the last parameter, but it kind of just keeps the code cleaner and improves code clarity, and that's optional syntax, but that's what you'll come across quite often. Touching on memory management, so I think I mentioned, but no, maybe I didn't, but by default, properties, when they're declared, are strong references. So in the example of a house class, if the tenant goes away, you don't want the house class to keep a reference to the tenant, so you can simply use the weak keyword, which hopefully looks familiar compared with Objective-C, because it's very similar. In this example, it's the same kind of, let's call that closure, let's call that block when the image finishes downloading, but let's say that this is called from within a table view or a collection view, and it's called from a class that maybe that image view goes away and gets replaced with another one. So what we don't want to do is, when this completes, pass the image into our image view. So so this is the block code, this is the closure code, but this is like telling the closure, this is how we're going to treat this reference to image view. So the image view, treat it as a weak reference. If that image view goes away, then don't hold on to it, because if we don't do that, it will actually hold on to it. So okay. All right, cool. That's the Swift bit over. This is actually probably my favourite part of the talk, because I feel like I discovered quite a few super cool things that you can do with these universal storyboards that are really new and new. They're introduced in iOS 8. So for those of you who jump onto the new technologies a bit quicker than I do, maybe I'll be telling you stuff you already know. But so in this section okay. So anyway, in light of the introduction of new screen sizes of the iPhone 6, iPhone 6 Plus, and future iOS devices, we're moving more in the Android direction, where we've got a program for many more kind of screen sizes. Apple have significantly improved the way that storyboards and auto layout enable us to create user interfaces that target multiple screen sizes, but with like a single storyboard. So anyway, in this section of the talk, I'm going to step through a few workflow videos that demonstrate how we can take advantage of these 5 powerful enhancements in Xcode 6. So pre-Xcode 6, if we created a new project from the iOS Universal App template, we'd end up with 2 storyboards added to our project, one for iPad and one for iPhone, which of course then means that we might focus our time on developing for one device, developing for the iPhone or developing for the iPad, get everything looking perfect, and then it's all about kind of duplicating that layout and getting it to work on the other device. And of course that leads to all kinds of issues when we come to add changes to our screen layouts in the future, and results in a lot of additional work to make an app universal. So in Xcode 6, templates for universal, So templates for universal iOS apps use just a single universal storyboard that, as I say, can target multiple devices. So here is a new project that I've created with an initial screen. So notice it's a square. That's intentionally telling us that this is an adaptive layout. This is not a layout for a square device. This is saying you're creating a layout and it's for all devices. So I think they're just kind of trying to hint that to us. But okay, so we've started designing a layout, and this layout we're actually designing for iPad. So I'm going to start this video here. We've got this really amazing thing that they added in Xcode 6 called Preview. And basically, without having to run this in the simulator, I'm looking at this, that says iPad there. So I've got like my assistant layout, and I can make changes on the left, and without running in the simulator, I can actually add, so here I've added another preview. So I've said I also want to check this out on iPhone. And then you've got all the different versions of iPhone as well. So this is all, and those changes will be shown in Interface Builder as you make them to the left-hand side.
Can you only have one layout for that device? So like with the iPhone, you've got to resize the text. Will that also resize for the larger version?
We're going to get to that. All right. In fact, we're going to hopefully get to that now. No, not on this one. Okay, so traits or size classes, they're also new in iOS 8. So these are abstract width and height combinations that basically define all of the different iOS devices. And what they enable us to do is kind of target combinations of iOS devices or a singular, like iPhone 6 only, different screen layouts. And we're going to see those in a second. So as I mentioned, our square layout on the left, that's going to, by default, we're targeting all devices. We've said we want to create a universal app. We want to make an app that's going to run on iPhone and iPad. And so by default, everything we do is being applied to both devices. So if we start this, I don't know if you can see this or not, but the button at the bottom enables us to change the width and the height combinations, and it's also telling us that the bottom right-hand corner is for iPad only, and that's saying regular height and regular width. This is we're targeting iPad with these changes. So what I'm actually doing here is I've changed it to compact width and regular height. So that basically means compact width and any height, which means all iPhones. And you'll see that it'll tell you that when you're kind of like working out what you're looking to target. So what I've added a new. What I added was a new label. Sorry, it was actually for all iPhones in portrait. So when I flipped to landscape here, that label disappeared. So basically, it's saying so you can basically use a single storyboard, and you can say, but I only want this view or this label to appear for this specific combination of width and height, so just iPhone in portrait or just iPad. So, so if you see the Let's Go button, this is it's like basically a regular UI button, but I've subclassed it with a tiny bit of code that's going to add a corner radius and add rounded. It's going to make it a rounded rectangle. So we can see this in the simulator, hopefully. So it looks like a rectangular button in Interface Builder, but you can see it's got a corner radius there. And this is our subclass here. Now, the IB designable, I don't know if you can see this, but we literally need to add IB designable to our subclass. And what's magically going to happen in a second, within Interface Builder, it's now rendering our changes like at runtime. How cool is that? I think that's super cool. And you can take it a step further and use the IB inspectable keyword on like specific properties of your custom class, like say the number of points for those rounded corners or whatever, and those will then appear in the properties panel of Interface Builder, so that they can actually be set. So you could like distribute custom classes and enable people to set those in Interface Builder.
I wanted that for 5 years.
It's awesome, isn't it? Okay, time to modify our universal storyboard and make it look great on iPhone as well as iPad. So basically, we're using auto layout, and if you don't like auto layout, you're just going to have to learn to like auto layout, because once you get your head around the horrible syntax, it's super useful, and it's used all over the place in these adaptive interfaces. So here we've set our welcome to glued is a 200-point layout constraint that's setting it from the top of its super view, which is clearly too high in the iPhone preview. So what we do, if I'm playing the video now, we've highlighted the label. So you see this plus button here. So that's the default. But now we're going to say, well, okay, for iPhone, we want to change that constant of 200 points to something lower, but only for iPhone. And so we didn't have to add a new constraint. We just said, if you're on this device, use a lower value. And then we can do the same with the font size. So we can add a custom font size, and we can target just iPhone or just iPhone in landscape. You know, it's a huge amount of flexibility. And then, yeah, just to prove it, it's now going to run on an iPad, and in theory, you'll see that the font size hasn't changed, and the.
Do you have to define that for every different iPhone?
No, so you can. It's totally flexible. So you can. That's why you've got these abstracted height and width combinations.
For example, couldn't you set proportional margins? So when it's in the square, so if left and right, top and bottom are proportional and they're a percentage. Therefore, when it goes on an iPhone, it's always going to be a proportional.
You can,
so
and you
set a single value, and then it would just
that you have that flexibility with auto layout anyway. Right. You can, it's you can literally drag and drop between subviews to say this is proportional to this, and what exactly. So you have that flexibility. That's been there for since iOS 7, I guess.
It looked like it was being clipped before, as opposed to scaling proportionally.
Yeah, I mean that's just that's really just to make for clarity on what these new features are. But you can definitely do that and have been able to since iOS 7 at least. Yeah, so we've got one last UI element to fix. Our people's icon is too big, well, at least in my designer's opinion, on iPhone here. So we've got a couple of options that we've already seen in previous slides to set that icon to be smaller for iPhone devices. So we could add width and height auto layout constraints that are specific to the iPhone that basically say, reduce it by a certain percentage, but only if you're on an iOS device. But what you're going to be doing is you're going to be loading up an image that was designed for an iPad and scaling it down. So that's not an optimal solution. Another option is we could add a second image view. So we saw that we can add labels, image views arbitrarily, and say this is only going to appear on the iPhone. So we could have two separate image views. That's another way. But it turns out there is a better way, which is through adaptive image sets in the asset catalog. So our icon, this has been around for, again, since iOS 7 or maybe even 6, with a 1 being a non-retina, 2 being a retina, and 3 being, well, now the iPhone 6 Plus, I think, has a 3 times. But you can actually modify this. So your images, if you have them in image catalogs, you've got these properties where you can say, I've got different versions of this image for iPhone and iPad. And I know you've had this in Android for some time, but obviously with all our new screen sizes that we're having to adapt to, this is the solution. There's a bit of copy in there for sure. That was a joy for me, that even though it's just like, seems so simple. Like, for example, I've got a button in an iPad app that's got a nice big icon in it, but I can size that button down in the iPhone app, but how do I change that button icon to make it smaller? Do I have to create another button and then keep doing this referencing? And I found out all you have to do is make sure that button's icon image is in your asset catalog, and then you've got all these options. So you literally don't need to touch the storyboard.
Do all the images get bundled in both binaries?
Yeah.
Do they get separated?
No, definitely. Everything will get bundled in. Mm-hmm.
You were saying that you don't really want to use iPad-sized images on an iPhone because of size and stuff. One thing I figured out was they can actually use PDF, and then Xcode generates the 1x, 2x, and 3x for you.
Okay.
So it's quite useful.
Sounds like a good solution.
Yeah, I just saw it stuck over. Was that really?
So I think that's. Oh yeah, cool. On to part 3. Developing for Apple Watch. This really is a brief intro. I kind of ran out of time, so. Okay, so in this final section of the presentation, I'm going to briefly cover these 4 topics. And it should give you an overview of the anatomy of an Apple Watch app and a few gotchas to be aware of if you're planning to develop for the device, which I don't have, but I'm apparently getting one tomorrow morning, which I'm quite excited about. But it's a shame I don't have it for today. Okay, so Apple Watch apps require an iOS. If you don't know this already, then this is going to be bad news. They require an iOS companion app, so you basically can't distribute an Apple Watch app unless it's part of an existing iOS app for iPad or iPhone. So what I've got here is the project from the last example. So it's an iOS project. It's targeting universal iPhone and iPad, but not the Apple Watch at the moment. So basically, in Xcode 6.3, you'll discover you've got this new target, the Apple Watch. And you've got these options to include notification and glances, which are a little bit beyond the scope of this talk. But basically, those are going to add additional views to your Apple Watch Storyboard, so you've got like a starting point. Anyway, you'll see that Xcode basically generates two targets when we start building for the Apple Watch. One is a WatchKit extension, and which is basically the brains behind the Apple Watch that's going to run on the user's iPhone, and then you've got a second target, which is the Apple Watch app, which is basically going to bundle up a storyboard and resources that live on the device. So it's kind of bizarre, but and I believe that's likely to change further down the line. But certainly from tomorrow, your all your kind of view controller code is going to live on the user's iPhone and is going to be wirelessly talking and telling the user interface on the watch what to do from the iPhone. All right. So first thing I noticed so we've got an interface, a storyboard for the Apple Watch here, is that there are a very limited number of UI components that we have access to as part of WatchKit. Notably, there is no equivalent to UI View. Okay, so you cannot build custom controls at this stage for the Apple Watch. And instead, although you'll see these graphics of kind of clever circles and animations and stuff, these are actually static or animated images, giving the impression of more dynamic UI that we're used to building on iPhone and iPad. And again, I'm sure that's to do with battery life, and I think that's going to change further down the line, but you are very limited. So another limitation when designing for Apple Watch is that we can't position components arbitrarily in the screen space. We've got no access to X and Y coordinates, no access to width and height properties. So basically, the watch is going to do, the WatchKit is going to do this for us, but we use these things called groups. So the group class can either size to fit the contents it contains or relative to its parent space. So you can align your groups top left centrally to the bottom within the parent group. Groups have adjustable insets, so they enable us kind of to add margins. I mean, this is kind of pretty limited stuff. And also note that groups can't overlap one another. So, you know, for this UI, I was trying to work out how the hell I was going to have my picture of the kid with even a text label over him. And the solution that I came up with was, rather than use a native image component for the child, I've actually had to make him a background image of a parent group. And so the parent group, then I can lay out nested groups. Okay, so here we're building, there are two types of navigation that you can choose to use in Apple Watch apps. And here we're going to build a page view controller, you know, with like the dots and being able to swipe between pages. This is incredibly simple. You literally drag, you create your view controllers and you drag between them, creating segues, saying next page segue. And WatchKit's going to do the rest for us, as we'll see. So I've literally duplicated a view controller. Hey presto. So you've also got hierarchical navigation that you can use. I don't have an example of that here, but you have to choose one or the other. You can't use both in the same app. It's hierarchical or page-based. You can also modally present view controllers on top of your content. Quite a useful view controller to mention is Apple have a built-in text input view controller. I can't remember what its actual class name is, but basically you can tell it display an array of text strings to the user, like hi there, do this, do that, whatever, and it's going to present it as a table view. And optionally adds Siri dictation, so you can basically say to the user, take your pick, or dictate manually, and it's going to get back, it's going to send back the text, the translated text, to the presenting view controller, so you can make use of it from that. A little bit of code. So the WatchKit extension target, remember I mentioned 2 targets. One resides on the phone, and that's the WatchKit extension, which is the brains behind the operation. So the equivalent to View Controller in iOS is WK Interface Controller, and these are your 3 probably most important methods that you can override. Awake with context, that's where you initiate any properties for this View Controller. This method just gets called once for your View Controller when it's first instantiated. Will activate and did activate and did deactivate. Those can be fired multiple times. So in the example with the page View Controller, each of those WK interface controllers, when it appears on the screen, just before it appears on the screen, will activate is going to be fired, and just as it's disappeared. So it's like view will appear, view did disappear. Good news is that you are not restricted to wiring up your Apple Watch View controllers on a storyboard like in my example. I believe you have to at least define them in the storyboard. But so for the Glued app, for example, I want to create one view controller that's a device view controller, and I want to, and you can do that, and then you can instantiate instances of that view controller in code. So the way that that I've achieved that so far is basically to have an empty root view controller. It's got nothing in it apart from the fact that when this method is called, it's got its data, it builds its data model. So let's say we've got 3 kids and yourself. So there are 4 instances of device view controller here that it instantiates here from the storyboard, but all from the same reference on the storyboard. And the context, although that just says 1, 2, and 3, that can be anything, that can be any object, and that's what's going to get passed in here. So in the example of my app, that's going to be like an instance of device, the model class that defines how long that kid's been using their device for, gets passed in here, and then the view controller can take care of the rest. Yeah, it may surprise you to discover that even though your Apple Watch extension code runs on the same iPhone as your iOS app, companion app, they can't communicate with one another. They have no way of communicating with one another. So this diagram from Apple actually describes this relationship. So this is actually the relationship of any iOS 8 extension, and so that's what WatchKit is for the WatchKit extension here. So that's the WatchKit extension that's controlling the Apple Watch app. That's your iOS, your iPhone, or your iPad app, and then this is just some host app that we don't really know about that basically determines when this starts and stops. Okay, so it's saying the user's tapped on their iPhone, they want to check out the Apple Watch app. Let's start the WatchKit extension here, but it can't talk to your iPhone or iPad app. So how does your iOS app, how do they share a data model? Well, that's what app groups are for. So app groups are basically they're a capability that you add in your Xcode settings for your iOS and your Apple Watch app. And basically, you're defining like a class path. And it's kind of like a shared data store. And it's like a sandboxed folder. So you can write from both apps to the shared folder via the kind of sharing options that we're used to, like NS user defaults,plists, or core data. You'll also find that you have to kind of carefully structure your object-oriented code if you want to share classes between your iPhone app and your Watch app. So, like for example, if you try and include a class that references UIKit on iOS in your WatchKit target, that's going to throw up errors because there is no UIKit on the Apple Watch. If you have any class that references the application singleton. That's going to throw up errors as well. So you really have to structure your code in the kind of MVC way. And also, if you want to, as a side note, if you want to use CocoaPods, you can use CocoaPods with WatchKit, but anything that references like the SV Progress HUD, if that's included in both targets, then that's going to cause problems. So you have to modify your CocoaPods file so that only the pods that are relevant and that are going to be compatible with Watch are included in that target. That just about wraps things up for me. Thank you.